All right, we're about to look at finding the value of a trig function at any angle or at any real number. But there's a couple things just real quick you need to recall from the right triangle trigonometry section. So the big idea there was figuring out how to determine the sine, cosine, and tangent. So sine was opposite over hypotenuse. Cosine was defined to be adjacent over hypotenuse. And tangent is defined to be opposite over adjacent. And so that had to do with in a right triangle, if you had an acute angle in a right triangle, you would just look at the sides relative to the angle, the indicated angle. So this would be the opposite leg, this is the adjacent leg, and this would be the hypotenuse. Okay. And then one other big idea from section 5.2 that we need this time are the ratios of the sides of these special triangles. If you had a 45, 45, 90 triangle, or if you had a 30, 60, 90, we wind up working with these quite a bit, and you need to know the ratios of the sides in here. So the side won't always have lengths 1 square root of 2, but they'll always be in that ratio. And you have to understand where they are on the triangle. Okay, that 1 and 1 are the legs and square root of 2 is the hypotenuse. But a lot of times we just say 1 square root of 2. And you have to know that goes with the 45, 45, 90 degree triangle. Okay. And then in a 30, 60, 90, okay, it's the way I remember it is 1, 2 square root of 3, but where I put them matters. So 1 is the smallest number, so it's opposite the smallest angle. 2 is the biggest number, so it's opposite the 90, and square root of 3 should be opposite the 60 then, okay? And so you need to know that. You need to know those ratios. You also need to know sine, cosine, and tangent, okay? But what's about to happen is we want to be able to find the sine, cosine, or tangent for angles of any size, okay? They don't have to be acute. And they don't have to be angles in a right triangle in order to have a definition, okay? So that's kind of what we're looking at in section 5.3 and 5.4, okay? So let me go ahead and get started working on that. Now look, I'm holding virtual face-to-face sessions. And a lot of you said that was essential. And there's a schedule out there of times when you can join me. Most of you said you're available after 7, so I went ahead and I'm doing my sessions from 7:30 to 9. So try to join if you can, okay? This first little area here, we're trying to work on figuring out how to be able to do the sine, cosine, tangent, and so on of any angle. Okay, and so what this is, the words up here are saying is that if you've got a point, and let's say the point is on the terminal side of some angle, so here it is right here, okay, it would have coordinates x, y, some x, some y. All right, the radius of the circle would be r, and it would equal the distance. It is the distance from the origin to that point. We could use the distance formula to prove this right here, or we could see it in a right triangle. Okay. If we dropped the perpendicular like that, you might be able to kind of see why things turn out the way they do by labeling. The horizontal piece would be the x coordinate of that point, and the vertical piece would be the y. So the trig functions can be defined, the trig functions for this angle right here can be defined in terms of x, y, and r. And sine turns out to be y over r. Cosine turns out to be x divided by r. And tangent of the angle is the opposite, which is y, over x. And like when you have your little triangle drawn, you can tie it back to what we did with right triangle trigonometry, because y is the side opposite, r is the hypotenuse, x is the adjacent side. So these are just a slightly different way of saying the same thing we said before. Okay, and then remember the connection between sine and cosecant, cosine and secant, and tangent and cotangent. Okay, the cosecant, secant, and cotangent are just the reciprocals of the sine, cosine, and tangent respectively. Excuse me. So I'm going to just do the reciprocal of each of those ratios. And that would be a definition that could be used to determine the sine, cosine, and tangent for any angle. Now, the picture I drew you had the point in the first quadrant, the terminal side of the angle in the first quadrant, but in reality, it's true no matter where, okay, you wind up having that. Now, tangent and cotangent have variables in the denominator that could sometimes be zero. So there's usually an extra little statement on those reminding you that you can't divide by zero, okay? And that would also be true here, right? On this one, you can't have y being zero. This one, you can't have x being zero. So there's usually that extra little statement. But on sine and cosine, r is the radius of the circle or the distance between the origin and the point on the circle. So it's always going to be positive. Okay. All right, so let's see what we would do or what we could do if we knew that P was a point on the terminal side of some angle. So I like to actually draw that pretty carefully in a coordinate plane. So there's 1, -3. Okay, and then draw the ray from the origin through that point. Okay, so this is the angle we're talking about right here. Okay, and then we need to think about what this would be, the radius here. You know, there'd be a circle. I'm gonna have a hard time drawing it, but there you could think of it. Think of a circle right here. Okay, containing that point. I'm not going to try to draw it. All right, so anyway, let's go ahead and think about a triangle. If we made a triangle right here, okay, dropping the perpendicular, that's going to be something we do a whole lot later, but I wanted to go ahead and just start right off the bat doing that. Okay, think about that point. That point, that 1, -3, okay, is a point on the circle, and then we could use the distance formula to get this length from the origin to that point. We could use the distance formula, which is what gave us r equals square root of, and then take your x and square it, take your y and square it, and then turn around and make sure you do the square root of all of that. So see how that turns out to be 10, square root of 10? Okay, that's the radius. You also can do it just by looking at the triangle and thinking about this as being 1. This length is 3, but it helps sometimes to keep the negative on it, especially when you're trying to do sine, cosine, and tangent later, okay? All right, so we wind up getting that this turns out to be the square root of 10, okay? That's the r. And then really we can use the formulas from above, or we can look at that triangle and do the sine, cosine, and tangent of the angle by just using those formulas, okay? So let's go ahead and just think the y over r. So y, that's -3 over the r, square root of 10, and then rationalize that if you need to, right? So we have to rationalize this. So we'd have -3 square root of 10 over 10. Okay, for cosine, we would do the x over the r. So that would be square root of 10 over 10. And then tangent would be the y over the x, and that would just be -3. All right, now this one did say to find the 6 trig functions. So that means we'd also need to do the cosecant. So cosecant of theta, and cosecant would be the reciprocal. So it's good sometimes to go to that step right there, and you can kind of see it's going to be square root of 10 over 3 and make it negative. Negative square root of 10 over 3. Okay, so cosine, you're going to do the reciprocal To do secant, you're going to do the reciprocal of cosine. So secant of theta is going to wind up being square root of 10 over 1, which is just square root of 10. And then cotangent is the reciprocal of tangent, so it's going to be negative 1/3. So really the key is getting those first three. So we can just think about the point being the x and the y, calculate the r by using the distance formula like we did. And we found out that r equaled the square root of 10. And then we can just use the formulas. But the formulas are connected to the right triangle work we did earlier. And so if you want to do that, build the right triangle, go ahead and keep the sign on the 3, keep the negative on the 3. And then this is the location that you would look at and determine what's the opposite side, what's the adjacent side, and the hypotenuse, okay? All right, so think about that, kind of make those necessary connections, and it just makes things a little easier. All right, let's look at this second problem I'm having you do. Here we're looking at what they call quadrantal angles, angles whose terminal side would be on an axis. Okay, what you want to do is take a look at, let's see where I'm going to draw it. I'm going to draw a little picture right here. Okay, take a look at where 180 would be. Here's where your terminal side would be. Your angle would go all the way to there. Okay, that's 180 degrees. All right, now if you think about this and you think about having a point right there, we could just arbitrarily designate that as being the point, maybe -1, 0. Let's just say it's 1 unit in radius. Then that would be -1, 0. And that would be our x and our y. Well, our r would wind up being 1. You could do it using the formula. Okay. I hope this shows up okay. You could use the formula to do that. Okay, or you could just look at how the radius of the circle is 1 to get r equals 1. All right, now once you get that information, you're ready to do like we did earlier. And so to do the sine, cosine, and tangent of 180, you do the y, which is 0 over r. You do the x, which is -1 over r. And then for tangent, you do the y over the x, and that turns out to be 0. Okay. Now, when you wind up doing the reciprocals on this, look at not the simplified form, but the original ratio. That's the best place to look. Then you can see that cosecant turns out to be undefined because you have division by 0, so it's undefined. Okay. Secant turns out to also be -1, it's also -1. And then cotangent turns out to be undefined because you have a 0 in the denominator, okay? All right, now here we have another quadrantal angle. Okay, this one would be here, right here is the angle we're talking about. Okay, designate a point on that terminal side. Okay, and if you labeled that, that would be like 0, -1. X would be 0, and the y could be designated as a -1. See how the radius would be 1 again? Okay, later we're going to do that a whole lot. And so then you can come in here and do the sine, the cosine, and the tangent of 3 pi over 2. And then once you get those, you just do the reciprocals to get the other 3. Okay, so sine would be -1 over 1. Cosine would be 0 over 1, which is 0. Get that autosave to stop. Okay. All right, so we got sine is -1, cosine is 0, and then tangent would be opposite over adjacent, or y over x, and that's going to be undefined. Okay. And so then we're going to do the reciprocal thing. So we're going to do cosecant of 3 pi over 2. And that's going to also be -1. Secant of 3 pi over 2 turns out to be undefined, doesn't it? Okay, because it would have a 0 in the denominator. And then cotangent is going to turn out to be 0. Cotangent of 3 pi over 2 is going to turn out to be, since it's 0 over -1, it turns out to be 0. Okay, so really all we're doing in 5.3 and 5.4 is kind of expanding our definitions for sine, cosine, tangent to enable us to do the sine, cosine, and tangent of more than just an acute angle. We can do it for any angle. Okay, now this right here is going to be kind of important. So really concentrate on this. All right, so what we're being asked to do here is think about what the signs of the trig functions are in the various quadrants. And there are mnemonic devices for this, but it's much, much easier just to think about which coordinate of a point is associated with the trig function, okay? So we're just going to look at the signs of the 3 basic ones, okay, in each quadrant. Okay. The reciprocal functions would have the same sign, SIGN, as these, okay? So let me get ready for this. Okay, and so just think about, you got your first, second, third, and fourth quadrants, okay? And that if you're a point somewhere in the first quadrant, your coordinates are both positive. If you're in the second quadrant, your x is negative, but your y is positive. In the third, both of them are negative. And if you're in the fourth, your x is positive, but your y is negative. So if you think about how the ratios we use, we always take like either the x or the y, and oftentimes we put it over r. But r, the radius is always a positive number, okay? So you kind of just think about being a point somewhere in each of these quadrants. And I want you to have in mind that if you're in the first quadrant, your sine, your cosine, and tangent are all going to be positive, okay? Because sine is positive because the y is, cosine because the x is, tangent because they're the same. Right now, when we come over to the second quadrant, see how the y coordinate is positive? So sine is going to be positive because it's y over r. So it's going to be positive. Cosine is going to be negative. And then tangent, because these are different, and you would have done the y over the x, tangent is also going to be negative, isn't it? Okay. And then in the third quadrant, sine is negative, cosine is negative, and tangent, though, is going to be positive because a negative divided by a negative would wind up becoming a positive number. Negative divided by a negative would equal a positive, okay? And then in the fourth quadrant, sine is negative, cosine is positive, and the tangent is negative since you would be dividing things that are different signs. All right, now this isn't something to memorize. It's really easy to think about. If you associate sine with the y coordinate, then that means sine is positive whenever you are up. Sine is positive whenever you have to go up when plotting a point. So I usually think of it that way. So sine is positive in the first and second quadrants because the y coordinate is positive there. Okay, cosine is positive in the first and fourth quadrant. When you're to the right, okay, when you're up is what you should think. Here, when you're to the right, cosine is positive. And then tangent is positive when you're in the first and the third, and that's because the ordered pairs have the same sign. Same sign on x and y. Okay. All right. So that's kind of the way to think about it, I think, is if you've gone up, then sine is positive. If you're to the right, then cosine is positive. This is going to be important when you're asked to determine the value of the trig function of an angle without using your calculator. Okay? And you'll have to be able to explain that to me. All right, now let's look at this problem number 3. All right, when you see that sine theta is less than 0, that means sine is negative, right? Sine is negative is what that's saying. You have to think about, well, for sine to be negative, sine is the y coordinate, so you'd have to be down in, so you'd have to be in 3 or 4, okay? Cosine negative, so that's cosine negative, you have to be to the left to have a negative cosine. Your x would have to be negative. Then that would put you in quadrants 2 or 3. Okay, so if both of those have to be true, then that means your angle has to be in quadrant 3. Okay, and so that means when later you're asked to try to figure out what the trig function is, a particular trig function is for the angle, when you draw the angle, you're going to want to draw it so the terminal side is in quadrant 3. Okay. All right, now look at question number 4. 4 says tangent is negative 1/3, and it tells you that the cosine of theta is less than 0. Okay, so cosine less than 0, that means you're to the left. You're in either 2 or 3. But tangent is negative. So for tangent to be negative, you have to have different signs on your x and your y, don't you? So that means you have to either be in 2 or 4. And if both of those have to be true, then that means you've got to be in quadrant 2. Okay? And we're being asked to find some trig functions. So we'll think about that in a minute, but let me get my picture drawn. Okay, tangent theta is negative 1/3. So remember how tangent of an angle, okay, was going to be y over x. Okay, now watch out though, because the negative can be out in front. Okay, so it means the negative could be on top with the 1 or on the bottom with the 3. And either way, you get a negative 1/3. But here's what I want you to think. Get your angle drawn, and then think about that 1 and 3. Those are coordinates of a point on the terminal side of the angle. So we're going to take that and the y over the x, and then we have to think about being in quadrant 2. That means that the 3 would have been negative. So that's the point we're talking about, this point right here. Okay, so let me draw my angle now. Okay, this is negative 3, this is 1. Okay, and then you can just use the formulas. That's kind of what they intend for you to do, to find the sine, cosine, and tangent of that. Okay, just to use the definitions with the y over r, x over r, and so on. But I like to look at the right triangle that we did in 5-2 and kind of make that connection as well. And what you can do is focus on this angle right here, which later we'll learn is a reference angle. And if you keep the sign, if you get the sign, S-I-G-N, like the negative, keep it on the 3, even though this is a length, then when you do your trig ratios, the sign S-I-G-N will be correct. So they just wanted me to find sine of theta and secant of theta. So for sine of theta, I'm going to be thinking about it needing to be the y coordinate over the radius. So I have to do a little work here to get the radius. Okay, so the radius of, or this distance right here, which I could think of as the radius of a circle or the length of that segment, can just be found by using the distance formula. So it'd be negative 3 squared plus 1 squared. We saw that earlier. That's just the square root of 10. Okay, so sine theta would be 1 over the square root of 10, which would be square root of 10 over 10 when we rationalize it. Okay, and it's positive. Now, when you do secant, let me raise that up a little bit. I'm really being asked for the secant, but what I'm going to think about is cosine first. Okay, so cosine would be the x over the r. Cosine of theta would be that. And so secant should be So then I go up here and say, okay, so secant should be square root of 10 over 3, and it'll be negative as well. Okay.